In today's video, here is a nice problem regarding arithmetic number theory. Here is the following setup. So our goal, we are going to prove this number, which is square root of n plus number 3 minus square root of n minus 3, is irrational number. Okay, so the question, this one is irrational number or rational number? We are going to see that by proof. We are going to prove this one by the way of contradiction. So we suppose this one is a rational number. At the end of the term, we will find a contradiction. Okay, so by the way of contradiction, suppose this number, which is square root of n plus number 3 minus square root of n minus 3, is a rational number, which is going to be written on this form: p over q. Okay, where is p and q as the natural number, and also GCD of p and q equals 1. Why GCD of p and q equals 1? Because they must be comprime integers. Okay, so this fraction is going to be reduced to the smallest fraction possible in order to get GCD of this one equals 1, which means q not divides p. Okay, so we are going to take this one as a tool, then we build our proof. If you take a look, we have a difference of radical here. So if I'm going to multiply this one by conjugate, I will have a new thing come up, is going to help us. Okay, so by doing that, I'm not going to do the conjugate now. I'm going to take the inverse of this one first. So I'm going to write this one q over p instead p over q. Okay, this one will be written on this form: the inverse of this one, which is square root of n plus number 3 minus square root of n minus 3, like this. Then at this moment, we have to multiply this one by conjugate. So by doing that, I'm simply going to multiply the numerator by square root of n plus 3 plus square root of n minus 3, because denominator will be multiplied by the same number. Now let's simplify this one. Numerator will stay the same. I get q over p. I get square root of n plus number 3 plus square root of n minus 3. Okay, all is divided by this one. As you multiply this one by this one, you get a difference of the squares, which means I get this radical will be cancelled out with this radical. I will be left with n plus 3 minus n minus 3. So a good news here, this n will be cancelled out from denominator. This is the reason why we conjugate that one right there. So I will be left with square root of n plus 3 plus square root of n minus 3 is divided by number 6. 3 minus 3, which is 6. Now I get q over p, which is this one. I'm going to take off this number 6. I'm going to put it here. I get this sum of these radicals equals 6 times is multiplied by q over p. At the above expression, we will have p over q. We have q over p. Let's bring this one down here. So if I'm going to sum both the expressions, I get this one cancelled out, I will be left with 2 times square root of n plus 3. So I get here 2 times square root of n plus number 3 equals this one plus this one. Now let's divide both sides by number 2. I get number 2 cancelled out from here. I get number 3 here. But this one I get 2 times here. Let's make a common denominator here. At numerator, I get 6 q squared, which equals to n plus number 3, like this. Then multiply side by side. I get here and square both sides like this, then simplify this expression. I get here, okay, this one, it will have also 4 times p squared q squared, and then this radical will be cancelled out. Will be left with n plus number 3, like this. Okay, now I have this expression. Let's distribute this one out. So if you take a look at the left and right side of this equation, we get 12 q squared p squared be cancelled out. Okay, so I will be left with 36 q to the 4th plus p to the fourth, which equals 4 times n p square q square. Now if we take a look at the right hand side of this equation, we get number 4. We get the right hand side of this equation is a multiple of number 4, which means that, so let's divide both sides by number 4 here. So I get here 36, you get 9 q to the fourth plus p to the fourth over number 4 equals n p square q square. Okay, so we know the right hand side of this equation is an integer, which means the left hand side of this equation is an integer as well. We know 9q to the fourth is an integer. This one also, this term also must be an integer. Okay, so in order to have this one an integer, which means number 2 must divide p. Okay, so one is telling us 2 must divide p. So if 2 divide p according to the divisibility statement, which means p is going to write on this form 2k. Okay, which means p is a multiple of number 2. Okay, let's take this value of p and insert it back in the same equation that I have here. So I get 9 q to the fourth plus p will be replaced with 2q, which is 16 q to the fourth over number 4, which equals n q square. P square will be replaced with number 4q square, because I have replaced p with number 2k. Okay, now let's simplify this one more. So I get here number 4. We know the right hand side of this equation is a multiple of number 4. The left hand side of this equation must be a multiple of number 4 as well. So let's divide both sides of this equation by number 4. So I get the following. I get number 9 q to the fourth over number 4 plus q to the fourth, which equals n q square q square q square. So we know this one is an integer. So we know the right hand side of this equation is an integer, which means the left hand side of this equation must be an integer too. Okay, let's put this one inside of this one. I get number 2 here. I get q square, all is raised to number 2 like this. Okay, to make it more visualized. Okay, so we know this one is an integer. Okay, in order to have this one an integer, we need to divide q. Okay, so this one is telling us 2 divides q. So we have two things here. We have 2 divides p, we have 2 divides q, which means GCD of p and q equals number 2, which clearly it's a contradiction, because we have contradicted our assumption. Basically GCD is supposed to be number 1, not number 2. Okay, so which means the assumption that we have chosen as a rational number, it was not true. This one is irrational number. Okay, so I have ended this video. If you have any question regarding this problem, just put it in the comment section below. If you have any suggestions, just put it in the comment section below as well. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.